Standard 9th, Subject Science and Technology Part 1, Lesson number 4, Measurement of Matter. In this chapter, we will study the subunits, laws of chemical combination, atom, shape, mass and its valency, then molecular mass and the concept of mole, and then we will study about radicals. Introduction. First of all, we should know what is matter. Matter is everything around us that has mass and occupies space. You can see here in the picture, we can see, feel and hold so many objects around us. All these objects have got mass and all of them occupy space. So they are all part of matter. We have seen that matter is made up of molecules. Molecules are formed from atoms. The concept of atom is more than 2500 years old. In the modern times, scientists on the basis of many experiments explained the nature of atom as well as the internal structure of an atom. It started with Dalton's atomic theory. John Dalton, a British scientist, explained his atomic theory in the year 1803 AD. According to him, all matter is made of tiny particles called atoms. Atoms of the same element are identical, whereas those of the different elements are different. Atoms cannot be subdivided, created or destroyed. Atoms of different elements combine in small whole number ratios to form compounds. Then he also said, in chemical reactions, atoms are combined, separated or rearranged. Thus, atom was accepted as solid, indivisible sphere of matter, and it was compared to the model of a billiard ball. Matter can be classified on the basis of their composition as element, compound and mixture. First, an element is a substance made up of only one type of atom. For example, the element of gold and oxygen. Then, second, a compound has two or more types of atoms chemically bonded together. For example, water is formed from hydrogen and oxygen. Second example, rust. Rust is a compound of iron oxide. Third type of matter is mixture. Mixture is a substance made of two or more elements or compounds not chemically bonded together. For example, air is a mixture of many different gases. Second example, seawater is a mixture of different types of salt, organic and inorganic materials. Now we know matter is classified as the three types: element, compound and mixture. And we have understood that how compounds are formed. Atoms of different elements combine to form a compound. A compound is a substance formed when two or more chemical elements are chemically bonded together. Here, the example of some compounds which you have studied earlier is given. First example, salt, chemically known as sodium chloride, molecular formula NaCl. Second, silicate lime, chemically known as calcium hydroxide, molecular formula CaOH twice. Next, water, molecular formula H2O. Next, lime, chemically known as calcium oxide, molecular formula is CaO. Next, limestone, chemically known as calcium carbonate. The molecular formula is CaCO3. From these examples, we have understood a very important concept which was given by Dalton, that molecules of a compound are formed by joining atoms of different elements. Laws of chemical combination. The composition of a substance changes during a chemical change. The fundamental experiments in this regard were performed by the scientists in the 18th and 19th century. While doing this, they measured accurately the substances used and formed, and thus discovered the laws of chemical combination. All the chemical reactions takes place according to certain laws. These are called laws of chemical combination. The various laws of chemical combination are: first, law of conservation of matter; second, law of chemical proportion. Here, we shall verify the laws of chemical combination with the help of some activities. Activity 1. In this activity, take 56 grams calcium oxide in a large conical flask and put 18 grams water in it. Observe what happens. We will find that calcium oxide reacts vigorously with water, producing hissing sound, as it is an exothermic reaction. Exothermic reaction means heat is produced during the reaction. So, here the chemical equation we can see: calcium oxide CaO reacts with water and gives rise to calcium hydroxide, that is CaOH twice. Here, calcium oxide and water are the reactants. Calcium hydroxide is the product. Now, measure the mass of the substance formed. We will find that the mass of the substance formed is about 74 grams. How 74 grams? 56 plus 18 grams is 74 grams. Now the question is, what similarity do you find? We find that total mass of the reactants is equals to total mass of the products. Next is write your inference. So what inference you get? During a chemical reaction, matter is neither gained nor lost. That means when calcium oxide and water reacts, they give rise to the product calcium hydroxide. The mass of the reactants, that is calcium oxide and water, is found to be equal to the mass of the product form, that is calcium hydroxide. Further, we will study the activity 2. In this activity, take a solution of calcium chloride in a conical flask and a solution of sodium sulfate in a test tube. Tie a thread to the test tube and insert it in the conical flask. Seal the conical flask with an airtight rubber cork. Weigh the conical flask using a balance. Now, tilt the conical flask so that the solution in the test tube gets poured in the conical flask. Now, weigh the conical flask again. Here, you can see when calcium chloride reacts with sodium sulfate, the mass of the mixture of calcium chloride and sodium sulfate is 300.23 grams. Then, due to chemical reaction, white precipitate of calcium sulfate in sodium chloride solution is formed. So, the products are calcium sulfate and sodium chloride. But now, again when we check the mass of the product form, we find that it is the same, that is 300.23 grams. From the chemical equation, we come to know that the chemicals which react during a chemical reaction are known as reactants. Reactants are written in the left hand side of the chemical equation, whereas the chemicals which are produced due to the chemical reaction are known as products. Products are written in the right hand side of the chemical equation. In the above activities, the mass of the original matter and the mass of the matter newly formed as a result of the chemical change are equal. French scientist Antoine Lavoisier inferred from his research that there is no rise or drop in the mass of the matter during a chemical reaction, and thus a statement was given: in a chemical reaction, the total mass of the reactants is same as the total mass of the products formed due to the chemical reactions, and this is called the law of conservation of matter.